Hey ladies and gentlemen, this is going to be our video lesson for GeoTrig Unit 8 Lesson 3, which is on coterminal angles. So you can see from our learning targets there's a couple things that hopefully you'll be able to do by the end of this lesson. First one, define coterminal angles, so just what are they? Second, find angles that are coterminal to one another. And very similar to that, determine whether or not two angles are coterminal. So if you're given two angles, determining whether or not, yes or no, they are coterminal. And lastly, we want to use coterminal angles in order to determine the value of trig ratios for angles that are not on the unit circle. So for example, our unit circle goes from 0 to 360 degrees. But what if we wanted to know the sine of 780 degrees, something like that? So that's what coterminal angles allow us to do. So later on in the lesson, we'll be utilizing the unit circle that we've been using the last couple days. But first and foremost, I want to start by defining what coterminal angles are. So by definition, coterminal angles are two or more angles that land in the same position on the unit circle and have equivalent trigonometric values. So in other words, the sine values are the same, the cosine values are the same, the tangent values are the same, so on and so forth. Now, coterminal angles can always be found by adding or subtracting multiples of 360 degrees. The reason we use 360 degrees is because that's one complete circle. So for example, if we start at 0 degrees and we rotate 360, it gets us right back to our starting point. Or another example of this would be if we are starting at 90 degrees and we rotate one full circle around, we would add 360 degrees to that 90, and that gives us 450 degrees. So 450 and 90 would be examples of coterminal angles. We see that below here in this diagram as well. So the angle we're familiar with is this 45-degree angle provided. Now, 45 is on the unit circle, but if we were to add 45 and 360, in other words, we're just going to do one full rotation from 45 degrees, that ends up equaling 405 degrees, and that's what we see right here. In other words, we're going from this angle, and we're hitting 45, but from that, we're going to continue to do one full rotation around. Likewise, in order to get this negative 315 we see here, that's just starting at the 45-degree angle, but now we're going to rotate or go the opposite direction to get to the same location 45 is at. So we're subtracting a full circle of 360, and that comes out to be negative 315. So in a nutshell, we can find coterminal angles by adding 360 or adding 360 multiple times or subtracting 360 from a given angle. So in our first example here, it asks that we circle all angles that are coterminal to 300. In other words, which angles land in the same position as 300 does. So the way we're going to do that is we are going to add 360 or subtract 360 accordingly and see if we land exactly on the numbers provided. So we are starting at 300. We want to know if 360 is coterminal to that. So essentially what we would do is we'd take our starting angle of 300, and since 360 is bigger, we would add a full circle of 360, and we can see that in doing so, we get 660. We have surpassed 360, so 300 and 360 are not coterminal angles. They land in different locations. Now, we can see that very clearly on our unit circle as well, that 360, which would be right here at 0, and 300 are not in the same place. Okay. So now we want to check, what about 660 and 300? So we're going to take the 300 we start with, we're going to add one full circle to get back to where we started, and we get 660. Therefore, yes, 300 and 660 are coterminal angles. Okay, the next one is 60. Well, 60 is smaller than 300. So I'm going to start at my 300 and I'm going to subtract 360. When we do that, we get negative 60 degrees. We were given a positive 60, so that is no good. However, on the next example, we see that negative 60 as the option. 300, what we started with, subtract 360, a full circle, just to get right back to where we started, and that is negative 60 degrees. So in other words, negative 60 degrees and 300 degrees are coterminal. For our next one here, negative 420. We start at 300. We subtract 360, and that got us to negative 60. Now, that didn't quite get us there, so we're going to take that negative 60, and we're going to subtract another 360, and that gets us to negative 420, so that works. Okay, if you want to do this on your calculator, you can. 300 minus 360 got us to the negative 60, so negative 60 minus another 360 gets us to negative 420. 780 is larger than the 300 we start with, so we add the 360. That gets us 660, not quite there. So we add another 360 to 660, and that comes out to be 1020. Well, too big for 780, so 780 and 300 are not coterminal, but sure enough, we see that 1020 there. Okay, so below, or what we have circled here, are 4 different angles that are all coterminal, or the same landing spot as 300. 660, negative 60, negative 420, and a positive 1080. Now, what example 2 is essentially asking us to do is, rather than it being a multiple choice and checking, we're just going to create 2 angles on our own. So we want to find 2 coterminal angles to 120 that are less than 120, and then we also want to find 2 coterminal angles to 120 that are greater than 120. So this is just a couple quick buttons on the calculator, or with mental math, either one works. 120 is the starting angle that we were given. We're going to subtract 360 to get our first coterminal angle that's less than it. So 120 minus 360 gives us negative 240. So that's one answer. And then we're going to take that negative 240 and we're going to subtract another 360 from that. And that's going to give us our second answer, negative 600. So these 2 are the 2 coterminal angles that are less than 120 degrees. Same landing spot on the unit circle, just different numbers overall. If we want 2 coterminals to 120 that are greater than 120, we just do the opposite. We're going to add 360. That's going to give us 480 as one of our answer options. Then we're going to take that 480, add another full circle of 360, and that's going to give us 840 degrees. So that's how we find coterminal angles greater than or less than, adding 360 or subtracting 360. So at this time, I'm going to ask that you pause the video so that way you can practice example 3. When you have your 4 total degree measures, 2 less than negative 30 and 2 greater than negative 30, go ahead and resume the video and check your answers to see how you did. Okay, so if I want 2 that are less than negative 30, negative 30 minus 360 comes out to be negative 390. So that's one of my answers. The second one is going to come from negative 390 minus the 360, and that should come out to be negative 750 degrees. Whereas if I want 2 angles that are greater than the negative 30, I'm going to add the 360, and that's going to be a positive 330. Then take that 330, add an additional 360, gets us right back to where we started, 690 degrees. Okay? Hopefully you got those correct. For our next example here for A, B, and C, essentially what we're going to be doing is we're just going to be checking, are the two angles that were provided to us coterminal? So similar to what we did in example 1, we're just going to keep adding or subtracting 360 until we either land on the number we want or surpass the number that we want. So for our first example, we have 210 and 1290. We just want to know, are those coterminal? Since we're starting at 210 going up to a bigger number, we're just going to add 360 to that. That's going to come out to be 570. Not quite where we want to be yet, so we're going to add another 360, and that's going to come out to be 930. Still not there, so I'm going to add another 360, and that gives us 1290, which is what we wanted. So yes, 210 and 1290 are coterminal. They are in the same location. Okay. So as a second example, 150 up to 1170. We need bigger numbers, so we're going to add 360. This comes out to be 510. We add another 360. That comes out to be 870. We add another 360, and that comes out to be 1230. Now, 1230 ended up surpassing 1170. So we did not land on it. 150 and 1170 are not coterminal. For the last example, again, I'm going to ask that you pause the video, work through it, get your answer. When you have your answer, go ahead and resume. Okay, so here we're at 30, and we want to check to see if negative 1410 is coterminal to it. So now since we're making the angles smaller, we're going from a positive to a negative, we want to subtract the 360. Now, in order to save a little bit of writing, I'm just going to go to the calculator and keep this minus 360 going. So, starting at 30, subtract 360, we're at negative 330. Again, the goal is negative 1410. So I'm going to subtract another 360. Not there yet. I'm going to subtract another 360. Still not there, so I'm going to subtract another 360. And there is our negative 1410. So, in the end, we end up with these two being coterminal. Now, all of this leads up to the overall concept of utilizing the unit circle. We really haven't used it for these questions. But now the last thing we're going to want to be able to do is what our last learning target was, which was use coterminal angles to determine the value of trig ratios for angles not on the unit circle. So for example, 480 degrees is not on the unit circle. However, we could find its coterminal angle that is on the unit circle and then use our unit circle to find what that value is. So for example, the sine of 480. 480 is too big, so I'm going to do one full rotation backwards to see if that brings me onto the unit circle, and that comes out to be 120. So whatever the sine of 480 is going to be the same as the sine of 120. Now, as we discussed yesterday in the notes, the sine value on the unit circle is whatever the y-coordinate is at that angle. So I'll go to 120 on the unit circle. At 120, I'm going to look to see what is the y value, since that is the sine value, and I see it's a positive root 3 over 2. So the sine of 480 is root 3 over 2, and that's it for that problem. Okay, let's take a look at the second one. Tangent of negative 150. Again, negative 150 is not on the unit circle. I need to add 360. Okay, so negative 150 plus 360 gives us 210. 210 is on the unit circle, so I want the tangent of 210. As we discussed yesterday, tangent is sine over cosine. So in other words, it's the y-coordinate over the x-coordinate at 210. So at 210, the y-coordinate is negative 1 over 2. And the x-coordinate at 210 is negative root 3 over 2. Now, as we talked about yesterday, you should always use your yellow calculators for this. Type that in, get your answer. But just one example longhand in the event that you don't have your yellow calculator. When we divide by a fraction, we discussed how that's the same as multiplying by the reciprocal. So I'm going to take the negative 1/2 that was on the top of the fraction, keep it. I'm going to take the negative root 3 over 2 and flip it, take the reciprocal, and then I'm going to multiply these two things. So as I multiply across the top, negative 1 times 2 is negative 2. As I multiply across the bottom, 2 times negative root 3 is negative 2 root 3. We can see that we have a negative 2 on top and on bottom, so those cancel out, and I'm left with 1 over root 3. Lastly, as we discussed, we're not going to see that as a multiple choice option on our tests. We're not going to have square roots on the bottom, so we have to rationalize this. And we said our shortcut was to basically move the square root up to the top of our fraction, 1 root 3, and then get rid of the square root on the bottom. Lastly, we're not going to see that 1 out in front. So our final answer is going to be root 3 over 3. The tangent of negative 150 is root 3 over 3. Now, the last one we'll talk about is number 7. We can see that we have the cosecant of 540. So just as we've been doing before, we're going to do our minus 360 to determine what 540 is equivalent to on the unit circle, and it's 180. So we want to find the cosecant of 180. Now, in order to know what the cosecant of 180 is, we have to know which one cosecant pairs with. Is it sine, cosine, or tangent? Cosecant gets paired with sine. So what we're going to first do is we're going to find the sine of 180 degrees. And then once we have that answer, we're going to flip it. So we go to 180 on our unit circle. And we want the sine value, which is the y-coordinate, which is 0. So the sine of 180 is 0. Now, because I want to flip that, I'm going to write it as a fraction, 0 over 1. Now, that's the sine of 180. So if I want the cosecant of 180, I'm just going to take this fraction, and I'm going to flip it. 1 over 0. However, we are not going to write our answers as 1 over 0. So as we discussed in our notes, anytime 0 is in the denominator, we are going to say that the cosecant of 180 degrees is undefined. Okay. Now, all remaining examples are, again, more of angles that are not on the coordinate plane, or I'm sorry, not on the unit circle. Negative 270, negative 45, 495, 980, so on and so forth. But the procedure you're going to do for each of these is the same. Determine what the coterminal angle is within the unit circle, and then use our unit circle values in order to determine what our final answer is. Remember that sine is the y values, cosine is the x values, tangent is sine over cosine, and if we have to do our reciprocals, cosecant goes with sine, secant goes with cosine, cotangent goes with tangent. There is a homework assignment available in the homework folder on Schoology. Make sure you get that done and have it ready to go for tomorrow morning or tomorrow afternoon. I'll have the answers ready to go. And if you do have any questions, please feel free to email me, send me a message through Schoology, or be ready to ask them tomorrow at the beginning of class. Thanks for watching, and I'll see you tomorrow.